Hello mathematicians, and welcome to Graphing Quadratics Day 1. For Day 1 you're just going to need the green sheet, so go ahead and have this in front of you. Obviously usually the green sheet is green, but on my iPad it comes up as white so you can easily see the notes. So what is a quadratic equation anyways? It sounds very intricate and mathematician smart. But in reality, a quadratic equation is a polynomial of degree 2. So what this means is that it's going to be examples like the following. So it's going to be similar to y equals x squared plus 3x plus 10. You can have y equals x squared minus 5x minus 20. You can have y equals x squared minus 2. Or y equals 3x squared. These are all quadratic equations. And if you notice, the degree of 2 is talking about the biggest exponent we see. This squared is very important. This is what makes it a quadratic equation. Now, when we talk about it, we generally have a format where we use variables when we don't want to use numbers. So usually we say that the format has ax, let me add another color, squared plus bx plus c. So to recap, using some vocabulary, a, b, and c, a and b and c are all variables, meaning that we're going to plug in these numbers, okay? They're just placeholders. And this 2 up here is our degree. Remember how I said it's of degree 2? That's where it comes into play. Now, what this unit is talking about is what happens when we graph them. So when we graph a quadratic equation, it makes something called a parabola shape. So let me come back on my color. Parabola. Now, this parabola shape looks like one of two things. It can either look like a smiling, so it can either be smiling, or it can be frowning. So let's give you some examples. This is a parabola right here. It looks quite literally like a smile. So when this is smiling, that is because the very first placeholder variable is bigger than 1. So it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as long as it's positive. So how about let's write that. A is positive. Or it can be upside down and look like it is frowning. And this happens when A is negative. Now let's further break down this parabola even more. What I want you to do is I want you to get some colors. And the first thing is we're going to draw our parabola like this. Oh, this is so ugly. Give me a second. Let's make it go like that. This is a parabola. Now, the first thing you might notice is that a parabola is symmetric, which means that if I were to fold this parabola in half, it would fold perfectly like a book. And that line is found right here. If I were to fold it like a book exactly on my blue line, it would fold and the edges would touch perfectly. So right here, with whatever color you're coloring that in, you're going to put axis of symmetry. Now, your axis of symmetry is usually an equation. So it's something like x equals blank. This is very important. The second thing is that our parabola has this very peak right here. This peak, which I'm again going to color it in here, this is called the vertex. And the vertex is usually a pair of points. Not a pair, it is 1 point. And remember that we usually write a pair of points as x, comma, y. The next thing that we have is the actual graph itself. So we have the actual parabola, which is made up of a table. Now our last two things are intercepts. So if we look closely, right here on our y-axis, our parabola is touching it at 1 point, which would be right here. So this is our y-intercept. And again, it's only touching at 1 point. So my y-intercept would be a pair of points. The last feature of our parabola is something called the roots. Oh, let me choose a different color. So our roots are where they are crossing with the x-axis, which we are here. So to recap, our x-axis is right here. So anywhere that our parabola is touching it will be called the roots. It's called the roots because in the tree, the roots are where the tree meets the ground. Now usually this can be, this is usually 2 points in which they are intersecting, right? We have 2 of them. So again, points are x, y. And so those are the features of our parabola. So go ahead and jump onto Delta Math, and I will see you for the next video.